Hi there, my name is Phung and this is my INFS 3208 project submission for the student competition. My project will be focusing on the motorsport series Formula One. Formula One is a sport that places a heavy emphasis on data-driven decision-making. This project aims to analyze the complex real-world data collected in F1 to identify trends that will assist the motorsport governing body and team principals in making informed decisions regarding safety and organizational regulations, as well as drivers for the betterment of the sport. These decisions are incredibly important in such a high-stakes sport, and so it is necessary that they are grounded in objective data and its effects continue to be monitored to assess the effectiveness. The data analysis has been done in a Jupyter notebook that's running on a virtual machine on the Google Cloud platform and interacts with a Spark cluster with 2 worker nodes to distribute computing resources. We also have a Hadoop cluster with 3 data nodes to store data efficiently and ensure that it is scalable as the sport continues to expand globally and more data is collected each day. The datasets used are from Kaggle and consist of data collected on the F1 World Championships from the beginning of the sport in 1950 to the current year. And we will be using these 7 for the project. So first off, I start by pre-processing the data so that it is ready to be queried. For example, for the constructors, which are the teams, I don't need the reference code, only the name of the constructors. The same goes for the nationality and the URL to their Wikipedia page. I'll also drop any columns with all null values as these do not contribute anything to the queries. You'll notice that I don't drop columns with some null values, as these are still relevant. For example, if a driver has not finished a race, their result will be null. However, we still very much want to know when they do not finish for the purposes of comparing performance consistency as well as how the reliability of F1 cars has evolved over the years. I also alter columns such as by concatenating drivers' first and last names with a space in the middle, since we don't need these to be separated for any reasons. I then create temporary views for each of the tables for the purpose of executing the SQL queries on them using Spark. Here, I also create a new CSV file in Hadoop which contains the total points of each constructor by year to simplify my queries, as you'll see later. This query takes the number of races where the driver has not been able to finish due to mechanical failures or other issues by year. When plotted, it shows the trend in how reliable cars have been over the years and allows the FIA, who are the governing body of the sport, to determine whether certain safety regulations implemented have been successful in reducing the number of crashes, as well as whether certain trends in car development are causing more dangerous situations for drivers. Leading up to the year 1990, you can see that there is a dramatic increase in the number of crashes. This corresponds to the development trends during that time, as cars were being developed with huge amounts of downforce, making it more and more dangerous to drive. The sudden drop after 1990 corresponds to new changes made to racing tracks to increase the safety of drivers, and such data allows the FIA to verify that these changes have been effective. This can continue to be referenced as more regulations are introduced to monitor and assess their effectiveness. This query shows the average lap times over the years per circuit as well as overall. As you can see, lap times have been growing more varied, with certain tracks being altered or longer tracks being added in. Variety is important to the sport and for fans' enjoyment, and so this graph can help the FIA assess whether they need more shorter or longer tracks. Additionally, for tracks that remain largely unchanged, the FIA can use these as reference points to see whether the regulations introduced are slowing cars down too much. There needs to be a delicate balance between safety and speed, as that is the main attraction of the sport. This is a function that allows the user to input a driver and the year in order to compare the performance during races and qualifyings of the driver to his teammate. It is very difficult to judge a driver's performance compared to the rest of the grid, since their performance will be heavily impacted by the quality of the car they are driving. However, it is very important for team principals to be able to accurately judge this, as a driver's contract can cost the team up to $100 million a year. One of the most accurate metrics that can be used to judge a current driver's performance is a comparison between him and his teammate due to them being in equal machinery. Hence, this helps team drivers inform their hiring decisions. For example, you can see the position of this driver Fernando Alonso has achieved in his races and qualifyings compared to his teammate. From this graph, it is clear that he is outperforming his teammate Lance Stroll by a significant margin, as well as being more consistent over the season. Team principals can then use this to infer that Alonso is currently the better driver to invest into. Here we can see the previously created CSV file being put to use. This query retrieves the percentage of total points achieved by the winning constructor of each year. This shows how dominant a certain team has been each season. Dominance is quite a significant problem in the sport, as fans often complain about races being boring when the winner is the same each race, and so the FIA can use this graph to assess the extent to which a certain team has been dominating over the recent seasons and put in place regulations that will allow other teams to catch up. In 1956, you can see that Maserati has the highest percentage of points. This is most likely because the sport was fairly new and less regulations were put in place, meaning teams could essentially do anything and spend any amount of money within their capacity, making the competition more unbalanced. From this point on, you can see that any time there is a spike in dominance, it quickly drops off in the following years. This is often due to regulations the FIA has implemented to allow other teams to catch up, and it appears to have been largely successful. With this graphic, they can continue to monitor the performance of teams in the coming seasons and use this to assist them in balancing the sport, similar to the example. With this, we can see that these analyses all play a role in assisting the FIA and the team principals in making better informed, data-driven decisions for the betterment of the sport. This has been my project, and I hope you enjoyed. Thank you.